Hello, and welcome to Technology Today. It is July 7th, 2024, Season 1, Episode 20. It is a time machine episode. I'm apparently losing my voice. I'm not quite sure what's going on, but it's been about a week. And I've been kind of losing my voice throughout the day. Anyway, I'm blaming allergies at this point, but that's not why you're here. You're here for technology news, science and technology news. Today, Mayor Watt is doing the show solo. The Sentient AI, the Sentient AI from the future is off on assignment, so I'm flying solo. I only have an hour. That's how the time machine works. And so if you want to catch this episode at some other time and past episodes of this and other shows from ohmTown, go over to YouTube and follow there and subscribe there, and also follow here. That's where we do it live and over on YouTube. And you can download the podcast, and soon we'll be posting everything over on Discord as well. We have a Patreon, and I'll be porting stuff over to the Patreon so that you can get access to stuff there. And we're going to be expanding into Patreon specific events. That said, you can also download the podcast anywhere you can catch pod. It gets distributed everywhere. All 7 of the podcasts, this Technology Today just being one of them. Anyway, we're going to be talking about changing farming forever, terahertz technology, a swarm of robotic bees mimicking cicada, images of an enormous volcano on Mars, a huge salamander-like predator before times, Webb catches a massive quasar merger, image recognition AI and battery condition, zinc could change farming, and gallium nitride and space. And I think maybe we have a duplicate that was submitted, but we'll get into it anyway. See you on the other side. All right, folks. Yeah, hopefully everything is working right. It looks like it's working right, but you never know. Anyway, let's get into the first article. Yeah, we actually have a duplicate, so, but that's okay. It might be 2 different takes from 2 different sources, and that's how it was submitted, and I allowed it through. If you are interested in all of today's show notes for Technology Today, you can actually hit !TT in the chat over on Twitch. I'll soon be attaching it over on YouTube as well, but we're not connected, not just yet. Anyway, if you hit !TT, it'll pull from ohmTown the information for today's show. If you want to get all of the podcast links, you can hit !pod. And if you want all of the show note commands so you can get them from specific shows, you can hit !show notes, and it'll give you all of the special commands to get the show notes. Okay, so this groundbreaking discovery, how zinc could change farming forever. Researchers have found that zinc significantly influences the nitrogen fixation process in legumes, a discovery that could transform legume-based agriculture. Climate change, drought, increased temperature, etc. have impacted the performance of crops. Helen Erickson from Aarhus University, I'm not sure how they pronounce it, put the article together for SciTech Daily. And it says here that this discovery, paired with insights into the transcriptional regulator known as fixation under nitrate, or FUN, I guess the FUN filtration, FUN transcription, has the potential to transform legume farming by enhancing crop efficiency and decreasing the dependence on synthetic fertilizers. By delving into the mechanisms through which zinc and FUN control nitrogen fixation, researchers aim to boost nitrogen availability, improve crop yields, and foster more environmentally friendly farming methods. So legume crops form a symbiotic relationship with rhizobia bacteria, which fix atmospheric nitrogen into the root nodules These nodules, however, are vulnerable to various environmental pressures such as changes in temperature, drought, flooding, soil salinity, and elevated soil nitrogen levels. By fixing it, basically it allows for a metered release of an appropriate amount of zinc. So I'll have to do a little bit more, or I should say regulates how much nitrogen gets released into the root system. So you want a certain amount, but fertilizers, they say synthetic fertilizers, but I will always argue about this. There are natural fertilizers that are just as tasty as the real thing, and it's not that big of a deal. I use a concoction of fertilizers when I'm doing my hydroponic growing of microgreens. I have a micro farm that creates essentially families worth of microgreens, like lettuce and stuff like that. And it does it in a very small footprint. I have 100% recovery. I don't have to worry about predation. I don't have to worry about bacteria. I don't have to worry about bad weather, etc. But it doesn't work at the macro level. So the natural order of things is to plant crops out in the open, but there's a problem here in that microplastics are regularly used because the soil is tilled up and then protected from predation by putting seeds underneath a plastic mat. And while it might be considered something akin to biofilm or something, that's not what it is. It's microplastics that eventually end up in our food supply. So I'm not really hip to all of that industrial farming side of things, but that's what keeps things cheap. So in the study, the scientists identified that FUN is an important transcription factor that controls nodule breakdown when soil nitrogen concentrations are high. FUN is regulated by a peculiar mechanism that monitors the cellular zinc levels directly, and we show that FUN is inactivated by zinc into large filament structures and liberated into the active form when zinc levels are low. So yes, it releases a little bit of zinc whenever necessary. And I don't know about releases it in a measured way. It's just that nature causes it to break down again, I suppose. This helps lay the foundations for future research that provides new ways for us to manage our farming systems, reduce the use of nitrogen fertilizer, and reduce its impact on the environment. Because eventually it always breaks down into the water table and then into our drinking water. And I've actually witnessed this where people are fertilizing their lawn, and then in areas that are outside their lawn, the area outside the lawn, like trees and stuff like that outside the lawn, are actually growing greener around that person's lot than where people aren't using commercial fertilizers. So it's pretty interesting, the knock-on effect of a greener lawn for a residence impacting the nature that's around it because of runoff. How this will impact the overall performance of crops, it really, as time goes on, we'll find out. But this is just fundamental research right now, and we'll see if it actually makes any economic sense to deploy. In the meantime, let's go on to the next article. This next article is over in Technology Today. Quicker than ever, breakthrough in terahertz technology promises faster data transfer. An innovative approach advances terahertz technology, facilitating faster data transmission and broader adoption. Terahertz technology has the potential to address a growing need for faster communications. Shinshu University put the article together, but it's published over at scitechdaily.com. So terahertz devices will greatly increase the speed at which data can be transferred and processed. This is kind of like no shit news at 1234. But as we approach terahertz over gigahertz technologies, Faster communication means more data in a shorter amount of time. The only problem with terahertz or any radio waves is that it's obstructed rather easily through anything with mass. And it can't go a far distance without a lot of power pumped into it. Mainly because if you just do a sound check, like a hearing test with a visualizer on YouTube, and you'll see what it means to increase frequency. And as you increase the frequency, there's more peaks per second. And as you hit terahertz, you're almost vertical. There's so much data in a short amount of time that it spends a tremendous amount of time inside something like a wall, or traversing long distance. It doesn't have sustainability unless you really amp up the power. So it says, as we plunge deeper into the information age, the demand for faster data transmission keeps soaring, accentuated by fast progress in fields like deep learning and robotics. Against this backdrop, more and more scientists are exploring the potential of using terahertz waves to develop high-speed telecommunication technology. However, to use terahertz band efficiently, we need frequency division multiplexing, or FDM, techniques to transmit multiple signals simultaneously. That's kind of what's been happening with all communication. CDMA or FDMA, FDM in this case, frequency division multiplexing allows multiple signals to essentially sit together. Of course, being able to upconvert or downconvert the frequency of a terahertz signal to another arbitrary frequency is a logical prerequisite to FDM. This has unfortunately proven quite difficult with current technologies, mainly because we can't separate efficiently what one signal is within the carrier signal. The main issue is that terahertz waves are extremely high frequency waves from the viewpoint of conventional electronics and very low energy light in the context of optics, exceeding the capabilities of most devices and configurations across both fields. Therefore, a radically different approach will need to be made to overcome the current limitations. And the article goes into talking about this in a recent study in nanophotonics. On May 20th, 2024, a research team including Assistant Professor Keisuke Takano from the Faculty of Science, Shinshu University, Japan, reported an innovative solution for the frequency down conversion of terahertz waves. The paper was co-authored by Fumiaki Miyamaru from Shinshu University, and others from other locations. The proposed strategy is based on the frequency conversion that occur in time-varying systems. Much like a waveguide combines a traveling wave packet in space, there's an analogous concept that occurs in time known as temporal waveguiding. Simply put, variations that occur across an entire system over time will act as a temporal boundary, similar to spatial boundaries, i.e., or e.g., the interface between two different mediums. Temporal boundaries can alter the dispersion properties of the waveguide, giving rise to different propagation modes at new frequencies. So I suspect that given time of release of the data within the terahertz wave, you can extract the information, but you would have to know what that is. So that's basically a protocol would be needed to extract the data from the terahertz wave. So as terahertz waves traveled through the waveguide in the transverse magnetic mode, they shined a light in the bare GAAS or Gauss waveguide surface. The resulting photoexcitation of the top surface instantaneously altered its conductivity, effectively turning the bottom metallized waveguide into a parallel double metallized waveguide. So this goes beyond my basic understanding of this. The research team ran experiments that ultimately validated their thorough theoretical analysis of the proposed frequency conversion method. Thus, the findings of the study paint a bright picture for upcoming terahertz technology. The same type of thing took place with fiber optics, where we started out with one beam of light being presented within the what acts as a waveguide, the fiber optic cable. And then we have transceivers on either side that can pick out individual frequencies within the fiber optic. And so you have many more lines of communication within a single fiber. So I find it really interesting that we're basically doing it, but at a terahertz wave or a terahertz level. I just don't know how far this can actually go, again, without a massive amount of power, depending on the medium by which the terahertz wave is being propagated. It's an interesting dilemma here. So that's why we talk about this higher level of fundamental science being conducted here in technology today. Let's keep going, though. The next article is over in the Marvel channel. Could we replace ingenuity with a swarm of robotic bees? Humans finally achieved controlled flight on another planet for the first time in just a few years ago. Ingenuity, the helicopter NASA sent to Mars, performed that difficult task admirably. It's now taking a well-deserved rest until some intrepid human explorer someday comes by to pick it up and hopefully put it in a museum somewhere. Yeah, I didn't know that Ingenuity actually was laid low. Interesting. So Andy Tomaswick from Universe Today put the article together, and it was posted over at phys.org. So yeah, maybe in the future we will have a whole bunch of bees flying around on Mars. They have a picture here of the Mars Bee, power-efficient, bio-inspired Mars Explorer. And its mission would be a 3D topographic mapping of Mars, and it would have wings. It would have a rover option that could be used for deployment and docking, charging, and maybe even data retention, recovery. The drone itself would have a communications module like all drones do, camera and sensors like all drones do, and avionics and battery like all drones do, except this one would be light enough that and maneuverable enough to manage itself on Mars. Seems like it would be kind of a no-brainer as well, but we'd have to understand better the physics of flight in the Mars environment. While we have an understanding of it, and a drone is a helicopter-like drone is fairly simple. Something flapping its wings like a bee on Mars, I think, is something that I don't think we're at that point yet, but the short answer appears to be not without additional technical development. Modeling the design showed weakness in areas that must be addressed before launching any successful Mars Bee mission. The biggest hurdle appeared to be how flexible structures like those that would make up the system's wings interacted with uncertain aerodynamic environment of the red planet. So, it's what I just said. Let's keep going. The next article is over in the Marvel channel again. By mimicking cicada wings, scientists are investigating new ways to keep patients safe. Cicadas' cries ring out in the hot air, and their discarded exoskeletons decorate tree branches in the southeast and Midwest United States at the height of summer. While their ability to emerge in huge numbers is astounding, they have other surprising features too. In fact, their wings kill bacteria on contact and are self-healing. Fascinating. I didn't know that. Shannon Brescher Shea over at the U.S. Department of Energy put the article together, and it was posted at phys.org. Researchers using the DOE's Oak Ridge National Laboratory and Brookhaven National Laboratory user facilities investigated this bizarre phenomenon. They learned how structures in the cells are able to pull off such a feat and how it could be used in medical applications. Self-healing would be spectacular. It's a superpower, you know? In 2012, researchers in Australia found that cells killed bacteria as well. They demonstrated it with a type of bacteria that is particularly resistant to antibiotics. That's actually very fascinating. Didn't know that either. So to microbiologists, this was an intriguing 1-2 punch. Medical devices are routinely sterilized with chemical antibiotics that kill off bacteria, but that ends up only killing a certain amount, not everything. Even autoclaving, depending on what it is, may not protect something from surviving. It may not destroy everything. It tends to, but there is always a chance. But they can't clean the dead cells off of surfaces. Unfortunately, dead bacteria and other biological waste make the surface dangerously attractive to even more bacteria. For example, about half of the bacterial infections in blood in long-term healthcare facilities are from urinary tract infections caused by bio-waste on catheters. A technology that could both kill and clean off microbes could be a game changer. Yeah, it makes sense. So first they needed to create the structures, polymers made of chains of repeating building blocks, ideal for creating tiny structures. To create the tiny structures, the scientists used a nanoscience technique called directed self-assembly. In addition to their own lab, the scientists used the tools at the Center for Functional Nanomaterials, a DOE Office of Science user facility at Brookhaven National Laboratory. So the technique can make dense, consistent patterns at the nanoscale level. The result, tiny squat cylinders that sat perpendicular to the surface, kind of like carbon nanotubes. To some on the pillars, the scientists also added a coating of titanium oxide, which is titanium rust. This material interacts with bacteria more than polystyrene does. Then come the big question, do the synthetic structures destroy bacteria as well as the natural ones? And to find out, they soak the structures in a nasty microbial broth for 36 hours. The test was a success, acting as both assassins and cleanup crew. The nanopillars both killed and eliminated the bacteria. In contrast, the flat surfaces made the same materials did not. Yeah, so it's at the nano level, and if it can't attach to it, then it falls off. So it makes sense. Now, how robust are the nanomaterials? Digging into the process, they go deeper into this, but I'm going to keep on moving through the other articles. If you want to know more about it, I'm sorry, we can come back and visit this when more information comes to light. The next article is over in the Marble Channel. Mars orbiting spacecraft captures snaking scar across the base of enormous volcano. The feature may have been developed as rising magma stretched and cracked the planet's crust. The article is over at gizmodo.com by Harry Weber. The deck statement says, feature may have developed as rising magma stretched and cracked the planet's crust. And I guess that's it right there. But there's several things that, because this looks like an older version of this, or not as deep a version as this. Interesting. So, high-resolution camera aboard Mars Express orbiter has returned stunning images of a snaking gash across the foot of Arsia Mons, one of the red planet's massive volcanoes. The structure, named after a spring nymph in Greek mythology, puzzles even today's experts. German Aerospace Center, which developed the stereo camera aboard the 21-year-old Mars Express spacecraft. It's 21 years old? You're kidding me. The agency added that some theories suggest that the trench is a tectonic one in nature, while others claim that volcanic veins formed during a late period of activity, creating scar-like depressions across both rocky and gently sloping terrain. Yeah, I mean, and this is what we see. I wonder what would be, because you can actually see it slowly rise up to the very surface and then deep down again. So what else is there under there that we're just not seeing because sands have blown? Pretty fascinating. So for its part, the ESA said Aganipe fossa likely developed as magma rising underneath the colossal mass of the nearby Tharsis volcanoes caused Mars crust to stretch and crack. Oh, and so that's it right there. But that's crossing over the volcano itself. So I wonder if that's kind of normal. I mean, you can actually see other striations Maybe it's all interrelated, but I don't know. They say the gashes across through gigantic marble-like patterns that consist of dust and sand blown about by Martian winds, according to the ESA. Yeah, it's pretty neat. Okay, let's keep going though. The next article is over on the Marble channel on ohmTown.com. Go over and become a citizen, and then you can hide articles, save articles. You can subscribe to article headlines and their little snippets so that when somebody makes a comment, you can actually come back and interact. You can favorite things and do additional things once you are signed in. So fossils show huge salamander-like predator with sharp fangs existed before the dinosaurs. Scientists have revealed fossils of a giant salamander-like beast with sharp fangs that ruled waters before the first dinosaurs arrived. So maybe we are lizard people after all. So this is a July 2nd, 2018 image that shows a nearly complete skeleton of, I guess, one of these salamander-like predators. Aditi Ramakrishnan over at phys.org put the article together. Has a neat picture. You can see the skeleton and what looks like plates on the head of something. The predator, which was larger than a person, likely used its wide flat head and front teeth to suck in and chomp unsuspecting prey, researchers said. Its skull was about 2 feet long. It's acting like an aggressive stapler. Although that's an extrapolation from incomplete data, I would say. Yeah. So fossil remnants of 4 creatures collected about a decade ago were analyzed, including partial skull and backbone. The findings on Gaiasia geniae were published Wednesday in the journal Nature. The creature existed some 40 million years before dinosaurs evolved. Oh, wow, really? That is fascinating. So most early tetrapod fossils hail from hot prehistoric coal swamps along the equator in what's now North America and Europe. But these last remnants, dating back to about 280 million years ago, were found in modern-day Namibia, an area in Africa that was once encrusted with glaciers and ice. Oh wow, is this really one of them? That's interesting if this is one of them. There's a picture on the site phys.org that shows, well, I mean, let's see. It's a 2014 photo provided by Roger M.H. Smith. Shows Claudia Marsicano, professor at the University of Buenos Aires, examining the new basal tetrapod fossil at the discovery site of a salamander-like creature near the Ugob River in Namibia. Scientists have identified a giant salamander-like predator with sharp fangs that likely ruled waters 280 million years ago. So it is fascinating to see something like this because it really pulls you back and makes you wonder, what else was going on in the world while this was evolving 280 million years ago? What else was out there prior to 280 million years ago that wasn't just a fern somewhere? This is amazing. I love this stuff. I don't know, some of the things that they extrapolate from this, it just makes me wonder, like, what the hell? This is retconning our existence because they make an assumption based on the information that we've had prior to this discovery, and then try to extrapolate back and say, oh, this is what it was doing, or this is what it is. I've always found it entertaining. All right, let's keep going though. The next article is over in Technology Today. Webb Space Telescope captures a staggering quasar-galaxy merger billions of light years away. An international research group utilized the James Webb Space Telescope to witness the dramatic interaction between a quasar inside the PJ308-21 system and apparently 2 galaxies. Italian National Institute for Astrophysics put the article together, but it's published at scitechdaily.com. The observations conducted in September 2022 unveiled unprecedented and awe-inspiring details, providing new insights into the growth of galaxies in the early universe. So this was how long ago? Oh, it says billions of light years away. So, I mean, the article that we just talked about was only 280 million years. So just think about all of the stuff, what we're witnessing right now in this, right? Billions of light years away. This stuff may not even exist anymore by the time today's light in that location were to reach us. It may be fading out or winking out of existence, like what would happen with a black hole. A black hole will eventually fade. Anything entering the black hole freezes in time as we watch, and then just slowly shimmers out of existence. So I find it interesting that we're using telescopes to look so far into what is our past, all because light is hitting something or light is being emanated from something. And then we go, oh, this is what's going on. Again, science is fascinating. But every 5 years, something old comes back and they go, oh no, we learned something else. So that's not true anymore. So the host galaxy of PJ 30821 shows high, I hate this word, metallicity and photoionization conditions typical of an active galactic nucleus, whereas one of the satellite galaxies exhibits low metallicity, which refers to the abundance of chemical elements heavier than hydrogen and helium. And we're really looking at just the light that's coming off of it to determine if there is this element or that element, and we kind of get and by we I mean us humans. I don't do this kind of work, so you basically get kind of a barcode of what that is, and then you know what is being emitted either from the star or by measuring the star, and then the light that is passing through or bouncing off of a planet. You can actually tell what is in the atmosphere or the surface of the object, the planet. So insights into cosmic evolution. The discovery has enabled astronomers to determine the mass of a supermassive black hole at the center of the system, about 2 billion solar masses, so 2 billion suns. It also confirmed that both the quasar and the surrounding galaxies are highly evolved in mass and metal enrichment, and in constant growth. This has profound implications for our understanding of cosmic history and galaxies' chemical evolution, highlighting this research's transformative impact. So eventually they're all going to merge, which is going to be pretty spectacular for anybody that's watching this. I'm not sure. I don't think the article actually is going to go into detail about what the future is in terms of like when they should come back and look at it. They just say future directions and implications. Thanks to the sensitivity of the James Webb Space Telescope in near and medium infrared, it's possible to study the spectrum of the quasar and companion galaxies with unprecedented precision in the distant universe. Yeah, and that's what we need, more and more higher resolution, higher fidelity research. That way we can get more fundamental data. So that's interesting. So just to look at this picture that is posted in that SciTech Daily article, map of the line emission of hydrogen and oxygen in the PJ 30821 system, shown after masking the light from the central quasar. The different areas of the quasar's host galaxy and companion galaxies in this map reveal the physical properties of the gas within them. So I wonder what is actually going to end up happening, because the supermassive black hole is going to pull everything towards it. and eventually gobble it up. But who knows what else is going to take place between then and now. Okay, let's keep going. The next article is over in Technology Today. Study employs image recognition AI to determine battery composition and condition. An international collaborative research team has developed an image recognition technology that can accurately determine the elemental composition and the number of charge and discharge cycles of a battery by examining only its surface morphology using AI learning. So the Korea Advanced Institute of Science and Technology put this article together over at techexplore.com. Let's see here. The paper is published in the journal NPJ Computational Materials. They've developed a method to predict the major elemental composition and charge-discharge state of NCM cathode materials with 99.6% accuracy using convolutional neural networks. I wonder how fast they know. How fast does it actually identify the quantity and quality? Interesting. So the research team decided that it would be groundbreaking if an automated SEM or scanning electron microscope or microscopy system could be used in the process of battery production, just like a semiconductor manufacturing, to inspect the surface of the cathode material to determine whether it was synthesized according to the desired composition and that the lifespan would be reliable, thereby reducing the defect rate. So I thought something similar to this is already done. Depending on how deposition is made for certain materials, optics are used. So I guess they don't do that with battery production of cathodes. The researchers trained a CNN-based AI application to autonomous vehicles, or applicable to autonomous vehicles, to learn the surface images of battery materials, enabling it to predict the major elemental composition and charge-discharge cycle states of the cathode materials. They found that while the method could accurately predict the composition of the materials and additives, it had lower accuracy in predicting charge-discharge states, probably because of variability in the chaos of weathering on the cathode. But let's see. One of the collaborating researchers of the project said, in the future, artificial intelligence is expected to be applied not only to battery materials, but also to various dynamic processes in functional material synthesis, clean energy generation, et cetera, et cetera, et cetera, et cetera. So yeah, it's probably because there's way too much variability to predict how the cathode basically breaks down. Yeah, they don't really say that much more. All right, let's keep going. The next article is over in Technology Today as well. That's the name of the show, and so we focus on tech and at a higher level than, plugging in a computer. Groundbreaking discovery: how zinc could change farming forever. And I think the first one, actually, these might be the same article, so I'm just going to jump over it. I won't make up for it. It looks like when I was going through building today's episode, I grabbed this twice, which, yeah, I might have accidentally done that, but that's okay. We'll move on to the last article for today. Technology Today: electronics that defy Venus's heat, how gallium nitride could revolutionize space exploration. Researchers are turning to gallium nitride for high temperature applications such as Venus exploration due to its ability to withstand temperatures above 500 degrees Celsius. The article is by Adam Zhu from Massachusetts Institute of Technology and it's published at scitechdaily.com. A recent study by MIT and other institutions have shown that this material, along with its ohmic contacts, remains structurally stable even at these high temperatures. The study involved building gallium nitride devices and testing them under high performance conditions, revealing promising results for future electronics in extreme environments. And here I'll show you something. So that is a GAN charger from Anker, and it gets up to 65 watts, and it's tiny. It's like a inch and a half by inch and a half by inch and a half. Pretty cool. And and it's extremely heavy. I don't know what all is in it right now. I've never taken one apart, but this thing could be used as an anchor. So in a new paper published in the journal Applied Physics Letters, which is part of a multi-year research effort, a team of scientists from the Massachusetts Institute of Technology and elsewhere sought to answer key questions about the material's properties and performance at extremely high temperatures. They studied the impact of temperature on the ohmic contacts in a gallium nitride device. Ohmic contacts are key components that connect a semiconductor device with the world outside. And when electricity is flowing into or through a power device, heat is generated, and that's where a lot of the inefficiency is. And so you basically the device has to weather that storm of electrons flowing, power flowing. Things get really confusing when you start talking about electricity and the electromagnetic field. And if you go and do a search online, that electrons don't flow through wires, and electricity isn't the electrons in the wire, but but a field outside the wire. Everything goes really wonky, and you end up in arguments with electrical engineers. Anyway, if you do a search on YouTube for veritasium and electrons or something, or electricity, and how fast electricity flows, it gets really kind of inside baseball real fast. So understanding how contacts perform at extreme temperatures is an important step towards the group's next goal of developing high-performance transistors that can operate on the surface of Mars. They studied the impact of temperature on the ohmic contacts in a gallium nitride device, and the researchers found that the extreme temperatures didn't cause significant degradation to the gallium nitride material or contacts. They were surprised to see that the contacts remained structurally intact even when held at 500 degrees Celsius for 48 hours. That would probably melt everything other than gallium nitride, typically referred to as GaN. So nowadays, while gallium nitride has recently attracted much attention, the material is still decades behind silicon when it comes to scientists understanding how its properties change under different conditions. One such property is resistance, the flow of electrical current through a material. A device's overall resistance is inversely proportionate to its size, but devices like semiconductors have contacts that connect them to other electronics. Contact resistance, which is caused by these electrical connections, remains fixed no matter the size of the device. Too much contact resistance can lead to higher power dissipation and slower operating frequencies for electronic circuits. So I know a little bit about a lot of stuff. And so when it comes to that statement, contact resistance, which is caused by these electrical connections, remains fixed no matter the size of the device, makes me want to go down a rabbit hole, because I don't recall that in my memory. I don't recall what that fixed rate is. Anyway, they tested that they could heat it to 825 degrees for about 30 seconds, a process called annealing. The second method involved removing chunks of gallium nitride and using a high temperature technology to regrow highly doped gallium nitride in its place, a process led by Rajan and his team at Ohio State. The highly doped material contains extra electrons that can contribute to current conduction. The regrowth method typically leads to lower contact resistance at room temperature, but we wanted to see if these methods still work at high temperatures. So they found that it did. Gallium nitride itself would degrade significantly. We went into it thinking that the contacts or gallium nitride material itself would degrade significantly, but we found the opposite. Contacts made with both methods seem to be remarkably stable. Yeah, pretty cool. All right, folks. Well, and to me, that's why I think GaN chargers are the way to go. I mean, we know something about it. All right, folks, that is it for technology today. I'm going to power down the time machine, and we will snap back to the front page. Boom. There you go. That's how this works. We go through 10 articles, or 10 or 9 and an extra one that just wanted to remind you that nitrogen and zinc work in releasing materials to plant roots. Go check it out. You'll have to watch the episode. I'm going to reset, and we'll do another show, Four Wheel Tech, which focuses on automobile technology, basically wheeled vehicle technology. I'm not sure when I'm going to do it. It might be in about 40 minutes or so. I'm going to take another break. See you in a little bit. And I'll be posting this over to YouTube and the podcast in short order. Take care. Bye-bye.